This is the question about that depth of water in meters at the end of a suburban jetty, which was modelled by the following equation above here. So I'm going to bypass all the questions A, B, C, D, E and go straight to F here. And we want to find the D double dash, which is the second derivative, and draw a sign diagram for it. And so to draw the sign diagram, we have to make that D dash double dash T is equal to 0. So we have to make minus pi squared over 12 sine pi t over 6 equal to 0. And I'm going to show you how to do it using the calculator. Before you get to the calculator, you should know that this is minus sine pi t on 6 is equal to 0. We can omit that pi squared on 12 because that's just a constant, but the minus needs to stay there. Now, using the calculator in your run mode, now press the option button, then F4 for calculate. Now you need to press the solve button, not the solve button F1, but the solve N button, which will be F5. And the reason for this is that trigonometric functions have many solutions, and the N will give you a number of solutions. You need to write minus sine pi x on 6, then put a comma, and then put x because you're solving for x. And yes, you'll get a warning sign where it says more solutions may exist. Just press exit. And now you have a series of solutions, and there's more to come. The ones that you're looking for are the ones that you want between 0 and 24. So highlight this row and push the button to the right. Scroll through until you get the solutions that you want. And you're looking from 0 to 24, so these are your solutions. If you press execute again, you'll get it in a different format. We can now use those solutions to draw up a sign diagram. To work out what the signs are, you can either manually insert values in your equation or go through to the menu section and press graph mode and put that equation in your graph. Either way, you'll see that we have a negative, positive, negative, positive. So this sine curve now tells us that on a negative interval, we will have a curve down, concave. And on a positive interval, we will have a curve up, which is concave up or convex. And concave and convex. And this is because D double dash T here is less than or equal to 0, whereas over here it is D double dash here is greater or equal to 0. How does this help us to determine, for instance, the times at which the depth is decreasing most rapidly? To find the decrease most rapidly, we are looking at concave coming followed by convex. In other words, we are looking for that graph going down, following by it going up. And that happens twice. It happens at 6 and it happens at 18. So it happens when t is equal to 6 and t is equal to 18. Those are times in 24-hour clock. You may want to say that it happens at 6 a.m. and 6 p.m.